So in part B, we're given a coil that is rotating with a magnetic field. We're given the angular speed of it. We need to state the magnetic flux linkage through the coil at t is equal to 0. And well, it's simply going to be 0 because the flux linkage is the number of field lines that go through the loop and are parallel to the normal of the loop. So the normal line is just this vector that is perpendicular to the surface of the loop, and we see we have no field lines going through the loop that are parallel to this vector. So it's 0. And in part 2, we need to draw the EMF versus time graph. We're given the angular speed. We know angular speed is 2 pi over t, so we can use this formula to calculate the period of oscillation. So we just plug in the angular speed, we get 0.5 seconds. So the period is going to be 0.5 seconds, and what is important here are two things. One of them is that at the start we will have a maximum EMF. Whether negative or positive is not so important here, but it will be a maximum because at this instant in time, when it turns a little bit, that's when we will have the largest change in flux. And since the period is 0.5, we need to make sure that one loop is created in 0.5, so one complete oscillation. So if we just mark up some points here, we'll have to come here. The amplitude should obviously be the same to the top and on the bottom. So I think somewhere over here, and then between these again. So it will just be this cosine graph. And then we can extend it one more. So here and here. So this is what it will look like.